Hello, everybody. Welcome to another episode of Obsertelligence podcast. I have two very exciting guests with us today, Mr. Ikuta and Mr. Guru. They've joined us from NEC, and I'm very excited for this podcast. I think we're going to discuss really great questions today. So bear with us today. And with that being said, gentlemen, welcome on board.
Yeah, thank
Thank
you.
you,
Yeah,
host.
thank you. Thank you.
So first, before we get started, could you please introduce yourselves? We can start with Mr. Ikuta and then move on to Mr. Guru.
Okay, so let me start from me. So my name is Masashi Ikuta, and I'm with NEC Platform Division of High Performance Computing, or HPC. So I'm based in Tokyo. So I'm connecting from Japan today.
Nice.
And I'm now focusing on the oil and gas segment. I have worked for NEC for 20 years. I started my career from software development, and I did many things together. I've made many presentations at many conferences, such as SC, which is the annual supercomputing conferences. So maybe Guru?
Yeah, thanks, Mr. Ikuta. So, host, thanks for inviting me here. So, my name is Gursimranjit Singh, but everyone calls me Guru. So, I'm a senior systems engineer at NEC, and I'm currently located in Irving, Texas. With NEC, my work responsibilities include supporting NEC's high performance computing related strategy in various industries in North America, including oil and gas. Good to be here.
Perfect. So we have from Japan and we got from Irving, Texas. You're pretty close to me. I live in Dallas, Texas, so we're pretty close. Okay. But gentlemen, thank you so much for joining me today. It's a pleasure to have you guys on board. So before we get started, can you tell me a little bit about who is NEC? Just a little bit of background about NEC before we get started with more detailed questions.
Yeah, sure. So let me take that question. So NEC is a global IT company, actually one of the Fortune Global 500 company. And we have 300 subsidiaries around the globe and over 100,000 employees. And NEC is a conglomerate with an extensive portfolio. Our biometric authentication is well known and used in 70 countries. You might use our system in one of the airports. Mm-hmm. We also do network infrastructure, including 5G. We are also well known for space technology, such as developing satellites. We have over 60 years experience here. And of course, computers, storage, servers, and HPC. So in general, our mission is to provide solutions to the society.
Got it. So NEC is a high-tech company, and you two are engaged in high-performance computing, which is which is basically like supercomputers. Can you tell me a little bit more about NEC's HPC?
Yeah, sure. So NEC is actually not new to HPC. In fact, we have been making supercomputers for over 35 years, I think now. In the past 3 decades, many of NEC's supercomputers have taken the crown of the world's fastest supercomputers.
Nice. Okay. So if I understand correctly, NEC makes gigantic supercomputers for cutting edge computations. Is that correct?
So I would take this question, host. So my answer would be here, yes and no. So up till year 2017, NEC used to make these gigantic supercomputers. But since then, NEC has taken this very radical approach to HPC or high performance computing. And what we have done is that we have introduced this a new line of supercomputers, which we call SX Aurora Subasa. So these new supercomputers by NEC, they have taken this a scalable and modular approach to high performance computing. By scalar and modular, what I mean is that now NEC's HPC systems are available in wide range of configurations. So these systems are available from tower configuration, which can have one processor, all the way to the traditional supercomputer configuration, which can host thousands of processors.
Nice. So what motivated this transition?
I would call it democratization of high performance computing. So traditional supercomputers, though gigantic supercomputers, they used to take a lot of space and a whole lot of power. And they were very expensive to purchase and even more expensive to maintain and operate. With NEC's these new HPC supercomputers called SX Aurora Subasa, uh, these HPC computers take a small footprint in terms of deployment, and even this small deployment footprint leads to smaller power and subsequent cost reduction. So with these kind of approaches, we have tried to make supercomputer technology accessible to even those users which have a limited computer hardware budget.
I see. I see. So has this transition resulted in a complete change of NEC's technical approach to high performance computing?
I think not really. As mentioned earlier, we have more than 35 years of supercomputing experience, and we want to build upon the technical expertise we have gained in all these decades and not completely abandon it.
Mhm.
So our latest model and all our previous supercomputers have one compute element in common, which is its compute processor termed as, we call it vector processor or vector engine. The biggest change we have done to our latest model is that we packed all our vector technology into a single PCI card, and we name it vector engine. So now the form factor is like a GPU. We connect our vector engine card to a x86 CPU server, but the architecture is completely different.
I see. So just for the average audience, can you explain like a little bit about what vector processor is? Because I believe the average audience doesn't understand that. So can you explain that, what a vector processor is?
Sure, Hose. There are various kind of computer processors. The most widely used and popular processors are called scalar processors, such as x86. These are processors offered by Intel, AMD, for example, and they are like widely used. Then there are other category of processors which are called SIMD processors. So these processors are GPGPU processors mostly. So if someone is involved in the visualization and HPC, they would know what GPGPU is. Vector processor by NEC, it's a kind of a SIMD processor, which is especially focused on sustained performance and throughput. And NEC's vector performance, sustained performance is enabled through this metric, which we call as bytes per flops ratio. So what this matrix is it basically defines the balance between a computer performance and memory bandwidth by using the ratio between various operations and by using the number of bytes that can be transferred while they are being executed.
I got you. So to be honest with you, this was pretty technical. So can you explain this and break it down in plain language so the average audience can understand that?
Okay, let me try this. So,
okay.
Well, yeah, I sometimes use this analogy. So our vector processor is like having 10 cows plowing a field, while our competitors do the same using 1,000 chickens. So only 10, but very powerful cores versus many, but less powerful cores. And when we talk about the memory, so we can compare this to a water pipeline and a straw. So our 10 powerful cores or cows are connected to a water pipeline, while 1,000 chickens has its own straw. So I think the point is, which do you think is efficient when you plow a field?
I see. I see. So basically, what you're saying, you have a smaller number of strong units, and which is more effective, basically.
So exactly, yes. So, but I need to admit that it again depends on what you want to do. It depends on the application. There are applications where 1,000 chickens might be better or efficient using 10 cows. But what makes us different is that we can provide what we call the hybrid solution. This means NEC can provide a system which consists of vector, but at the same time x86 or CPU or GPGPUs. You can run the right application on the right platform.
I see. I see. So, so could you explain a bit more about the right application on the right platform?
I'll take this, host.
Sure.
So basically, we talked about various processors which are currently available in the market. And the reality is that any processor, no matter how capable it is, cannot work in optimal compute capability across all the computer programs which are currently available. And that is the truth. So rather than perform less optimally with a certain program which is more suited to some other architectures such as x86 or scalar, NEC vector processor can simply offload this scalar-friendly portion of that particular program to the scalar processor. So it gives that program the portion which that processor is more suitable. So in this way, a vector engine coexists with other compute architectures, and also in this way, it creates a hybrid computer architecture.
I see. I see. So how about any benchmarks that you guys have done?
So yeah, actually we have done many benchmarks, but I think we can prove that our processor is efficient compared to others if we can show our HPCG benchmark performance. The HPCG is one of a new metric for ranking HPC systems. And so actually we are not at the top of the list because we don't use huge systems to measure the performance. But if you see the efficiency efficiency of the performance, you can see that we are very outstanding there.
Okay. Okay. So does a user have to buy a special x86 or a scalar processor to utilize this hybrid compute capability offered by the vector engine?
So I would say no, Hose. So NEC vector engine systems, NEC SX Aurora systems come with single or multiple NEC processors, which are called vector engines. These are vector processors created by NEC. And within one system, many multiple of these vector engine cards are connected with one or more than one x86 processors, such as Intel and AMD CPUs. So if there is one computer program which can benefit from vector engine, then what the system will do is that it will make that program run completely on NEC's vector engine cards. But if that program kind of benefits from the scalar or x86 processor as well, then what the system will do is that it will create this hybrid compute architecture where x86 and vector engine, they can work together in a hybrid fashion to tackle the computer program's problems.
I see. I see. So is NEC the only company that is developing these vector processors?
I think this is a pretty interesting question. I would say yes and no at the same time. So I would say yes, because when it comes to real vector, I think NEC is the only vendor developing this. But at the same time, I would say no, because Intel processors, AMD processors, or NVIDIA GPGPUs, they have vector-like or tiny vector features. They might have heard the word AVX, which is the Intel version of the vector features.
I see. So why has NEC been continuing to develop real vector processor?
As I answered previously, so vector processor has some technical advantages for various applications and calculations, which are suited to its unique processor architecture. And there's these programs and applications come from various industry segments which can benefit from vector engines prowess. So to provide value to these market verticals, we have been continuing to develop the vector processors. We have been making vector processors for more than 35 years, and we have a very experienced team with very deep technical know-how and experience. Um, Please understand that we are not just the developer of vector processors. We also see, from NEC's perspective, we also see these different processing architectures in the market, and we are not denying the prowess of other architectures. We see that many other architectures have their own special advantages, and NEC is the supplier of high performance computing platform and solutions. So what we try to do is that we rather than fighting with each and every processor architecture out there, we try to select and combine various suitable processor technologies with our own vector processors. So in this way, we try to supply the best value HPC platform and solution to our customers.
I see. I see. So what can you talk to me about, like a little bit about what use cases or customers do you guys have right now?
Yeah, so we have many customers, but I'll just touch upon the biggest customers that we have made till date, these customers are using SX Aurora Subasa computers that we have made since 2018. The first customer I would like to talk about is DWD, which is a German weather agency, and they specialize in weather and climate related use cases. So currently, I believe they are doing these weather forecast in Germany using our vector computers, and they do various kind of climate simulations as well. So this is DWD. Then we have a customer in Japan, which is called NIFS. It's a National Institute for Fusion Science, and they basically do plasma simulations using our vector processors computer systems. Then we have another customer where they are developing Earth Simulator. I think Earth Simulator is something which has been developed for many decades, and this is this Earth Simulator that I'm talking about right now. It's a fourth generation Earth Simulator. So this is being used to do many Earth science related activities, including the geoscience, which is the oil and gas related. Then we have various academic customers. So a wide variety of academic activities such as fluid dynamics, nanotechnology, development of new materials, disaster mitigation, all those kind of use cases have been implemented using NEC Vector Engine. What I hear from our customer is that they find Vector Engine, a technology particularly good for academia, because they feel that it's very easy to get high performance from NEC Vector Engines with investing a minimal amount of effort. So if you take a look at the other architectures such as GPGPUs, you have to go through a special frameworks and special programming to get advantage from their architecture, but that is not the case. So this is particularly very well taken by our customers all across the globe.
I see. So how about, my favorite topic, some of the AI machine learning applications?
Yeah, so let me take this. So yeah, everyone's today talking about AI and machine learning, and of course we are interested in this. And so, but AI machine learning is very broad, and so let me explain in stages. So first, category-wise. So when we talk about category, our vector architecture is good in statistical machine learning and data frame. On the other hand, we think applications categorized as so-called MLP or LSTM. I think these would be good to run on GPGPU architectures. And then framework-wise, we have our own framework named Provedis. And so Provedis, actually, this is a Apache Spark clone or scikit-learn clone. I think Apache Spark and scikit-learn, these are the ones that are widely used in AI machine learning today.
Yeah.
So if you have an Apache Spark or scikit-learn application, I think it might be interesting to try our architecture. You might have a good chance to accelerate your program.
I see.
And finally, category-wise and use cases. So let me pick up some commonly used algorithms where ethics or Subasa can shine. The first one is logistic regression, which I heard is the kernel for recommendation. And second one is k-means. which is used for demand predictions and price predictions. And I also like to touch the third one, SVD, singular value decomposition. So SVD, I think this is also used in various areas, but let me pick up one important example. I think we often use it is for risk mitigation analysis.
I see. So you touched on really two of the, one was logistic regression, supervised learning, right? The other one was k-means clustering, if I say correctly, right?
Yes.
Yeah, which as the data set gets larger and larger, I personally have experience with that. It takes so long to run these clustering algorithm, and then the last one was the singular decomposition analysis, right?
Yes.
Yeah, these are very powerful like algorithms that I think timing has been an issue. So you guys have done some of these applications like within the oil and gas industry, right?
Yes, so we're trying to do this, and
Okay. So can you name a few specific oil and gas applications that can benefit from NEC's vector machines?
So let me take this, Harsh. So I think there are many seismic applications which are widely used in the oil and gas industry. And to name a few, I would say full wave inversion or FWI, reverse time migration or RTM, and reservoir application for which tools like Eclipse from Schlumberger are being used. So all these applications, FWI, RTM, and reservoir applications, they are very, very memory bandwidth dependent. And we think that this is one area where our vector architecture can definitely contribute. So we because our architecture is so strong in the memory bandwidth, we believe that we can improve any oil and gas company's success rate in exploration. We can reduce their failure cost, and we can also reduce their delay related cost. And we can at the same time improve their recovery factors as well. So this is all possible because we can do computation with higher resolution thanks to our vector architecture. So to summarize, I believe oil and gas applications will definitely benefit from our vector architecture's strong interaction between memory and CPU.
Got it. I think I forgot to ask one question before jumping to that question. And that question is, so NEC is trying to get into the oil and gas market now. So why has NEC started approaching this market like now?
Well, I think there's a couple of reasons for this. First, because we wanted to contribute to the society. You might have heard the United Nations initiative called SDGs. And yeah, it has 17 goals in total, and one of it is related to energy. I think it was the goal is to ensure access to affordable, reliable, sustainable energy for everyone. And so I think we would like to contribute here, and we believe we can contribute here. And the second reason, because we think oil and gas applications are suited for vector architectures. I think we just touched this, and we had actually, as Guru said, we have many customers in academic, climate, and earth science. And actually, in the past, we also had oil and gas companies in our customer list. And as we downsized our product and changed it from the gigantic supercomputers into the small vector engine cards, I think we are expecting the vector processor will be selected by oil and gas companies again. So we just wanted to retry to enter this market again.
I got you. So how about some AI and machine learning? And like, how do you see your chances there?
Yeah. So we are definitely evaluating some of AI machine learning applications in the oil and gas industry vertical specifically. I think a couple of years back, not couple of but like 5 years back, the trend was like HPC and AI/ML used to be thought as completely different technology spheres, but that is not the case anymore. I think the recent trend is like converging of HPC with the AI machine learning techniques. So I think Mr. Ikuta just talked about various AI ML areas where NEC vector engine can contribute, such as demand prediction, price prediction, and risk mitigation analysis. And we believe that all these problems are not unique to any industry in particular. I think these problems are dealt in the oil and gas industry as well. So we believe that these NEC vector engines capabilities in AI ML are also applicable to oil and gas vertical. And additionally, I wanted to touch upon that we are working very closely with Dr. Fred Aminzadeh. I think he was one of your previous guests of your podcast series, and he is having this AIM-D program at University of Houston.
Yeah.
And just to advertise here a little, so NEC is also a vendor partner of the AIM-D program. So we are planning to benchmark and implement various AI and machine learning applications on our supercomputer technology processor.
I got you. So to fill the gap between coupling domain expertise and the statisticians, how are you guys planning to fill that gap in your company, especially in the petroleum industry?
Right. So, we are HPC experts, not somewhat familiar with oil and gas yet. So as my colleague Guru said, we are working closely with Dr. Fred Aminzadeh, and he is giving us much needed guidance on what we need to do to get into this market or satisfy computing needs to the oil and gas companies. In different areas from seismic imaging, reservoir simulations, and also AI machine learning as well.
I got you. So can you tell me a little bit more about your activity with Dr. Aminzadeh?
Yes. Actually, I think we're very pleased, and I feel lucky we are working with him. Not only because he has great insight to oil and gas. I think you know him personally. He's very energetic, passionate about bringing new technologies and capabilities to address big E&P challenges. To be honest, we are learning a lot from him. And actually, one thing we are doing with him recently is that we are conducting a survey of HPC usage in oil and gas. And so I think we're trying to both learn about the market and HPC usage together.
Yeah, Dr. Aminzadeh, I had the pleasure of having him on one of the previous podcasts, and as you said, a very passionate guy and very knowledgeable. He's actually one of the pioneers, like I'm sure you guys know that, in machine learning applications in the oil and gas industry. So now with that, you talked about the surveys. You guys are sending out some surveys to kind of gauge the industry. Can you tell me a little bit about some of the questions that you guys ask in these surveys?
Yeah, sure. So the objective of the survey is to, learn oil and gas industry's recent positioning in with respect to the HPC and AI machine learning. So our objective is to learn, the current latest insights with regards to that. So we have a list of, I think, two dozen questions in the survey, and some of the questions that we are asking is we are asking the user whether they are currently utilizing high performance computing systems, or are they interested in doing so. If they are using HPC systems, how they are using it, and what is the configuration of their current hardware and software, and not only HPC, because we want to learn the AI/ML implications, implementations in the oil and gas industry. We are also asking many AI machine learning questions, and also questions related to the HPC and AI/ML cloud as well.
I see. So what was the reaction? What has the reaction been so far from the people regarding the survey by the NEC?
I would say, the people are very cooperative, and the answers we've got so far are pretty useful for our understanding in the oil and gas market. We are going to use these answers for strategic rating or planning to get into this oil and gas market.
I got you. And can you share some of the results from these surveys you guys have done?
Yeah, sure. Yeah, sure. So, yeah, as we discussed, we talked about the applications, and we confirmed that many of them are very memory hungry or data intensive.
Mhm.
And yeah, speaking about the hardware, we learned that many people are already using not only x86 CPUs but also GPGPUs, and yes, that's one findings. And when we talk about, many people today talking about cloud as well. And it was very interesting to find that some people are very cloud oriented, but on the other hand, there are dozens of people who are not at all interested in cloud. So that was another interesting finding for us.
I got you. Yeah. And so, do you have any plans to disclose the entire survey results?
Yes. So, as I mentioned, we are reaching out to many players in the oil and gas industries, especially the players and the companies who are a very significant contributor to the direction of computing systems in the oil and gas vertical. So, what we are trying to do is that we are taking these answers from these participants, and we will evaluate all the answers and then make a report, and we are planning to make this report public. So if anyone who is today listening to your podcast and who wants to participate in this survey, I would request them to please contact us. Every participant who will participate in the survey, they will receive a complimentary copy of our survey results, and that should be very insightful, I believe.
Oh, okay. Yeah, we can put probably your email address, at the bottom of the podcast. People can have access to that and request those surveys. Okay, that's good. And then, so have you demonstrated or planning to demonstrate oil and gas related computing capabilities of the NEC's vector engine?
Oh, yes,
Hmm.
we have. So we have for the general HPC, we have demonstrated our capabilities across many shows and conferences. But if we talk about the oil and gas, we participated in this event called SCG 20. So SCG is a big oil and gas event, this year it was very different because it was virtual, but we participated in that, and we were honored that one of our study was selected to be presented at the event. So this study, we had made this with collaboration with this very reputed company called NAG, or Numerical Algorithms Group. So this was a combined study which was presented over there, and the topic of the presentation was how the seismic applications can be optimized on our SX Aurora Subasa HPC systems. So this is the one oil and gas event that we have recently attended, and in addition to this, we are also planning to take exhibit at Rice Kennedy's Oil and Gas HPC conference. So this happens in Houston every year, and I think it happens generally in the month of March. So for the March 2021, we are planning to exhibit over there as well.
I got you. And have you done any or planning to do any kind of benchmarking or porting of vendor software to NEC?
Yes, we have. We are continuously working on the key question on where we can add value to address oil and gas customers' problems. And so I'll give you one example. So we have recently started to help port the DGB's Open Detect open source software to our HPC computer environment. And we also have done some porting for the open source software named Madagascar. That is for seismic processing and imaging. And we're also considering a couple of other portings on top of that, including those in the areas of reservoir simulations as well. So indeed, if anyone of this watching this podcast is interested, you can contact us. We can have some discussion that if we can work together on your application.
Got it. And who is your target customer?
I think we can divide the potential customers to three categories. The first one is, of course, oil and gas operating companies. I think there's literally thousands of oil and gas companies. Some are huge, some are not so large, but I think all of these oil and gas companies are going to be our target customers. And the second category falls to academic customers. I think we told you that we have many, academic customers. And I think there are universities well known for petroleum engineering and earth science. I think, we would like to see those as our customers. And the third one is the service companies, especially providing service to the oil and gas industry. So I think these three categories of customers we are looking at.
Okay. And how can one buy or try your system?
Yes. So before buying, if any user or company wants to try out our systems, we have implemented our systems trial uses over the cloud. So especially given the current geographical climate, I think a cloud-based trial is the best option, and we have done that. So if anyone is interested in trying out our systems, please contact us so that we can arrange a free trial environment for you. And also in North America in particularly, we are not selling our systems on our own. So we have partnered with many partners here who sell our Japan made HPC systems in America. And one of the partner is Colfax International, and they also have this trial system implemented on the cloud. So you can either use NEC's Japan-based cloud or Colfax US-based cloud for trying out our systems. In addition to these trial systems, what we have recently done is that we have implemented a series of online workshops. So these workshops are basically hands-on 1 hour, 2 hour session where user can just come in, log into our systems and execute various programs on our system. So they can do these hands-on activities on our system and get to know in the real time how they can actually benefit from our architecture. So with various academia and institutes, we have implemented these hands-on workshops in last 3 months, and we have plans to do continue to do these workshops in the future as well.
I got you. Okay. And what's your given your vision, what's your current expectation in the US market?
So NEC is a Japan-based company, and we are in terms of HPC systems, we are pretty well established in Europe and Asia Pacific. So our target with our HPC system is global. It's not focused to a particular country or region. Having said that, I think the North America and US market is very important for NEC because it's one of the biggest market in the world. It's very innovative market, I would say, and because it's a very innovative market, US market has a lot of influence on other markets. So usually innovations happen here, and then other markets kind of follow that path, which is being established here. So so we would definitely like to learn from the US market, and as part of this learning activity, we are doing this oil and gas survey in the HPC here, and also slowly and gradually we would like to increase our presence here through sales opportunities with various industry markets here.
I got you. No, very good. I definitely learned a lot today from HPC, and so gentlemen, would you like to make any final comments?
Yes, so let me make the final comment first. So yeah, thank you, Horst, for having us today. And I would like to thank everyone for watching this to the end. Hope your audience will be interested in our product. So if you need more information or if you have any questions, please contact us, or you can post an email or visit our webpage. I think your host, you can put a note at the end, or so I think our email address is info@hpc.jp.nec.com, and our webpage is www.hpc.nec. Yeah, so I'm waiting for contacting us.
We'll put all these information right underneath the podcast so people can have ease of access to contact you guys about the surveys, about maybe a trial as Mr. Guru mentioned, and Mr. Guru, you have any final comments?
Yeah, first, thank you so much, host, for giving me the opportunity to speak today. I thoroughly enjoyed our conversation. The final thing that I want to emphasize here is that our HPC compute architecture not just allows our system to be utilized by not just these big oil and gas companies and big institutes and organizations in general, but also by these smaller companies who can access our systems at a relatively low cost. So essentially what we are doing is that we are trying to bring high performance computing to the masses while satisfying the needs of very heavy users. So this is the conclusion I would like to make.
Yeah, sure. Yeah. Thank you so much, gentlemen. Appreciate the feedback. Appreciate the perspective you guys have. This is a high performance computing is one of the areas that I'm definitely like learning and I'm very interested in. Again, appreciated both you guys' time, one from Texas and one from Japan, Tokyo, Japan. And with that being said, thank you everyone for tuning in today to the Obsertelligence podcast. Hope you guys liked it. If you guys liked it, like and share. And leave a comment. Thank you so much. And we'll see you guys in the next podcast.